Welcome to the level 3 robotics. Level 3 is all about different type of sensors, and on the top of that sensors how you make your robot. So we are mainly focused on the three different type of robots that you can make in this level. The first one is very famous line follower robot, which consists of line sensor. It detect color of the surface, and depending on that it perform its operation. Second one is the obstacle avoider robot. It detect obstacle which is surrounded to the robot, and it detect all those obstacle, and depending on that it decides exactly where the robot has to travel, like it has to go straight or left or right, or it has to stop. Exactly these type of decision these type of robots made. And third one is a self-balancing robot. It consists of some sensors, IMU sensors. On the basis of that, this robot is try to balance itself by its own. So this is all about the level 3 robots. So level 3 robot consists of one additional feature, that is nothing but a sensor, and one is basic switch just to make to provide some bit settings operation. So sensor is nothing but any kind of sensors. In our case, sensor can be a line follower robot sensor, or else it can be obstacle avoider sensor, or it can be a MEM sensor, or any different kind of sensor that you can use in this specific level. And rest of the everything is same: power section, processor, indicators, motor controller. Processor is nothing but you can consider any 8-bit microcontroller. Most commonly people use Arduino as a processor or controller. So you can decide anything whatever you want. You can use Raspberry Pi as well, depending on your convenience. Indicators are nothing but the basic indicators, like 16 cross 2 LCD display, or else a single LED, so that indicators can show exactly what is the state of your robot, so that on the basis of that you can predict, yeah, our robot is in this specific states, and it has to go to this state, next state. So what you learn in this specific level. First one you will learn, that is the most important concept in robotics, control theory. That is nothing but basic controls. So basic controls consist of P, PI, and PID. P stands for proportional control. Stands for like proportional integral control. PID consists of proportional, integral, and differentiator control. There is one more, that is PD, that is proportional and derivative control. So these are the good examples of classical control theory, and even nowadays people still use these kind of concepts in order to correct some action, in order to correct some error. So all these different controllers consist of a basic error, in this robot, self-balancing robot. You can see that it is tilting, like up and down, front and back. So that is nothing but a error, and that error value you have to your system has to correct with respect to the speed of these wheels. So that is nothing but controllers designing. So that thing is consist of in this specific domain. So the same error can be generated using these sensors and this obstacle avoider sensor, and on the basis of that you can correct that error within a minimum time, and you can provide some corrective action to your robot. So that is what all about this basic controls. Second one is a closed loop systems. So previous all the cases you have seen the open loop system. Open loop system is nothing but if you press a button, then your robot will move forward. If you press your button backward, then your robot will travel in reverse direction, and it will take left or it will take right depending on your button states. But there is no mechanism to get a feedback from your robot. But in this specific domain you get feedback. You get feedback from, in this case, line follower sensor. You get feedback from this obstacle sensor. In this you can feedback from this IMU. So on the basis of that you can decide exactly what your robot has to do and what is the real-time state of your robot. So on the basis of the sensors, whatever you are reading. So these kind of thing that you can read in this closed loop system. Closed loop system is a very big part of control systems. So you can decide like exactly what to do and what not to do in this closed loop system designing. Third one is a sensor data handling, like uh, like in this line follow robotic sensors, it has consider it has 6 sensors or 8 sensors. So 6 sensors data is continuously generating, and that data you have to process simultaneously. Like it's not like you are processing data for first sensor, second sensor, but you have to process everything in a single machine cycle, so that you will get exact movement of this or movement of that robot. So that is a different mechanism to read the data. In this IMU sensor, is not like a single pin sensor. It is depending on I2C protocol. So I2C protocol consists of 2 lines, and the 2 lines sends data for like gyroscope and accelerometer, 3 parameters each, so 6 or 9 parameters in total. So you have to process all that thing into your sensor handling thing. So in this domain, this ultrasonic sensor SR04, it completely based on like echo and trigger. So you have first we have to trigger the pin, then we have to receive exactly what level of pulse that we are receiving. So on the basis of that, we have to predict, yeah, that is the distance of the obstacle from my robot. So these kind of things that you'll learn in this specific level, the sensor data handling. And the most important is the sensor fusion. Let's consider so these examples are very individual. Like this example is line follower, obstacle detection, and this one is self-balancing robot. But let's consider you have something like you have to follow line with balancing the robot. So in this specific domain, you have to fuse 2 different sensor readings into the single one. So it has 6 sensors which detect line. It has IMU sensor which balances itself. But if you want to do combination of these two, then you have to fuse these two readings. These two are very basic things, but there are multiple things that came into the picture, like encoders, then IMU, and like different kind of things. If you have more everything together, then obstacle sensor, then you have to fuse everything together, and you have to make your system more reliable and feasible to perform this kind of operation. So this is all about sensor based robots. I hope you like this video. If you have any question, you can comment below. Thanks for the watching, guys. Bye, have a good day.